Today we are going to be talking about the Polygon Sum Conjecture. So we're going to be talking about interior angles of all polygons. Tomorrow we'll be talking about exterior angles of polygons, but today is all about the interior. The first conjecture on your conjecture sheet is the quadrilateral sum conjecture. So as you remember, quadrilateral means all shapes with 4 sides. And the quadrilateral sum conjecture is talking about the interior angles. So any quadrilateral, notice I have 6 different examples up here, the sum of the measures of the 4 inside angles will always add up to 360 degrees. Okay, so if we have a square, obviously 90, 90, 90, 90 would add up to 360 degrees. Okay, so all 4 of the angles, if I add them all together, they will be 360. We also have the Pentagon sum conjecture. The sum of the measures of the 5 interior angles of a pentagon, of any pentagon, those 5 angles add up to 540 degrees. It doesn't have to be a regular pentagon. It can be any kind of pentagon, just like the one shown. So all 5 of these angles will always add up to 540. The Polygon sum conjecture is for any polygon. Okay, so the first 2, quadrilateral and pentagon, okay, those obviously are just for quadrilaterals and pentagons. However, we can also find them using the Polygon sum conjecture. So the Polygon sum conjecture says if you want to find the interior angle measures of any polygon, so n is just what they use for like sides. Okay, so like if we were trying to find a 6-sided, a hexagon, okay, then we'd have 6 there, the 6 interior angles of a hexagon. Okay, so we have a formula to help us with that. We do 180 times n minus 2. So how do we use this? Let's say we're trying to find the sum of the interior angles of a hexagon. Okay, I would take 180. A hexagon is a 6-sided shape, so I'd put 6 in there. So I have 180 times 4, because 6 minus 2, so I get 720 degrees. Okay, all hexagons add up to 720 degrees. Okay, let's say we wanted a quadrilateral because we just forgot that it was 360 degrees from our conjecture. I would take 180 times, quadrilaterals are 4 sides, minus 2. 180 times 2, 360 degrees. So we can always find those first 2 conjectures using the Polygon sum conjecture. Sometimes they might say, well, what's the interior sum of a 31-sided shape? Okay, so if we had a 31-sided shape, we do 180 times 31 minus 2 and solve. Okay, so this is for interior angles only, and it's the sum. So it's the angles together added up, the total. That's the part a lot of people tend to get mistaken. But you should find this part kind of towards the back of your conjecture packet or your vocab packet. And we're going to fill some of it in today, some of it in tomorrow. First, you can fill in the number of sides. So triangle has 3, quadrilateral, pentagon, so on and so forth to 10-sided. Then the interior angle sum. That's what we literally just talked about. Okay, so if you need to, you can use your 180 times n minus 2 to help you find them. Triangles always add up to 180. That was our triangle sum conjecture, if you remember from chapter 4. We have our quadrilateral sum conjecture and our Pentagon sum conjecture. We found a hexagon in the last slide. Okay, and then you can put 7 in for n into our equation, and you should get 900 degrees. Then 1080 degrees for an octagon, 1260 degrees for a nonagon, and a decagon, 1440 degrees. Okay, now that is for this sum. Now we can also fill in the next level because it's asking for one interior angle. So this is for if these are regular polygons only. Okay, so this is for regular, if all the sides and angles were the same. Okay, if we wanted to know one of them, let's say I wanted to know one angle in this triangle, 180 divided by 3 would be 60 degrees if it was a regular triangle and equilateral. If I wanted to know what one angle was, 360 divided by 4 be 90 degrees, a square is technically our regular quadrilateral. Then we could keep going to our pentagon, okay, taking 540 divided by 5 if we had a regular. Okay, regular, this is the line where it's only for regular. Obviously, irregular shapes, they'd all have different types of angles. Okay, and then we'd have 120. Okay, and you can continue filling in the rest of this column by taking the number I have in green and dividing it by the number in red. Okay, you will get some decimals, just round to the nearest tenth. We will fill in the last 2 rows tomorrow.